Hello everyone, welcome to session 13 of QA training. In this session, we are learning equivalence partition. Equivalence partition. If an application behaves in an identical way for a set of values, then it is known as equivalence class or partition. The functionality of the application would be the same for any data value within the equivalence class or partition. In equivalence partition, the data input is analyzed and divided into equivalent classes, which will produce the same results. In order to test this, we will implement the partitions wherein the results would be identical for a set of data input, and then pick values from each of the partitions for a complete test coverage. Equivalence partition can be applied for all levels of testing. Equivalence partition includes both valid and invalid partitions. Valid partition means those partitions would result in the correct results of data is taken from those partitions and tested. An invalid partition, on the other hand, includes values that are not specified to be tested but can be entered into the application. Ideally, when we are using these invalid partitions, we should get an error message. If we are not getting, we will raise that as a defect. Let's take an example. For example, consider an application which shows the grades of the students based on the marks. So here anyone scoring between your 0 to 39 is grade D, 40 to 74 is grade C, 74 to 89 is grade B, and between your 90 to 100 gets the grade A. Here the mark range specified can be, here whatever the mark range is specified, that can be considered as 4 partitions. If a student scores anything within that specified range, the application would invoke the associate grade for that student. So values within the partitions are considered equivalent. Let's take an example. Say for example, student Brain, if he scores 77 in his test, then the system should show the grade as B, because Brain score 77 comes under the partition 74 to 89, and the output of the same would be B. In addition, inputs that are not part of any partitions, for example 105, if you see here 105, this is not part of any partition. That means here we can say that this is a invalid. So here 105 is the invalid input. And also you can say that non-numeric value would be classified as invalid input. Let's continue with the equivalence partition. In most real world scenarios, partitions can become really complicated due to multiple ranges in the input values. For example, consider preparing the test cases for an online clothing store. To prepare test cases for the system, the simplest type of partition would be to begin with 2 partitions like menswear and womenswear. So this is a simple thing to start with. But the range of the clothes does not stop with these 2 classes. Menswear again further have partitions like shirts, t-shirts, trousers, and so on. Similarly, women's clothing partitions can increase as, again it is having different partitions like your shirts, tops, skirts, dresses, and so on. There can be further partition based on your brand, based on your price range and so on. So for a complete coverage of this inventory, for this complete coverage of this inventory tracking system, you would prepare partitions for all these levels and then identify valid and invalid input for each of the partitions, and then finally run your test cases for each set of partitions. So to summarize, equivalence partitioning technique requires only one test case for each partition. To make sure that most specifications of the system are tested, you should identify as many valid partitions for your application as possible. That's all about equivalence partition. Thank you, team.